Hey guys, I knew something would go wrong. We were looking at yesterday's video, so maybe we can run that back. Let me switch this back over. Had a pretty good time-lapse clip. So let me see if I can bring this up just a second. We're going to get glitches like this every now and then. It's just inevitable, so I can't find it. Anyway, I'll have to figure that out later. So let's go ahead and head into tonight's weather. And it's really not a whole lot different from what we had yesterday. Just kind of the same story. You can see we had stratocumulus back where we were, just overcast all day. Temperatures, however, did rise up to the upper 60s. And we got a lot of winter storm advisories up in the northern tier states. Let's see, I had a couple of astronomy notes I wanted to point out. If any of you actually have clear skies, the planet Mercury is reaching its greatest elongation. So it's the furthest separation between the sun and the planet. And that's about, that's going to be out to the southwest. We showed that a couple days ago, and you can check that out. And Mercury will become brighter on Tuesday. And another thing about Tuesday, we got a meteor shower coming up. That's the Geminids. So you might want to mark your calendar for that. It's been pretty windy here. We've had a low-level jet in place. If we had a little bit more low-level moisture, we would probably have thunderstorms today. So if I outline the area of 50-knot winds, there it is right there. And Texas is located right down in this area here. So it's a very veered jet stream pattern, and that tends to scour out the moisture. When we have moisture working its way northward from the Gulf, that gets carried eastward pretty readily by those strong low-level winds. And this is the sounding at Fort Worth here. And there's those strong low-level winds, 50 knots right there. But you can see the cold air is still pretty deep, all the way up to about 8,000 feet or so. And very humid, all the way up to about 6,000. And up above that, this is kind of the tropical air. And one good way you can tell, if you extend this down, sort of between the dry and wet eddy bats, kind of like this, you can see we get a surface temperature of about 21, 22 Celsius, which is about 70. So that's definitely part of a warm air mass. And then this part down here, that's the cold air mass near the ground. And once again, that's at the Fort Worth sounding. Let me take a sip of my drink here. One other very interesting sounding we can take a look at is pretty close to the North Pole. This is alert in the, I want to say Northwest Territories. I think it's in Nunavut now. We can use that same principle way up there near the North Pole. So here's a very similar pattern. If we extend the upper level air mass down to the surface, we come up with a temperature of about -5 Celsius, which is about 23 Fahrenheit. So is that considered warm up there? This time of year, yeah, it's considered very warm. So maybe this is not really the tropical air mass, but we can consider this a warm air mass right there. And anything below that is a cold air mass. And in this case, this is what we refer to as continental Arctic air, or just Arctic air. So the top of the Arctic air inversion right there, that's going to be up at about 7,000 feet or so. And below that, we've got about -30 Celsius. That's about down in the -20 Fahrenheit range. And you can see how low the tropopause is. Now, sometimes it does get a lot lower when the whole thing is filled with polar air. That'll come down all the way to about 18 to 15,000 feet. But yeah, the tropopause is a little bit high for that area, come to think of it. So, let's take a look at the weather picture here in the U.S. And let me get the map started, or centered. And I'll take a look at the chat and say hello to everybody. It's good to see everybody here, the regular folks here, Mark and Sue and Ron. And I really wanted to write down where all you guys are. I know where a few of you are. There's a few in New Hampshire. There's one in Indiana. If you can post in the chat, and when I finish the weathercast later, I'm going to write that down. So that way I can kind of focus on your areas when we have weather going on. 8 to 12 inches for Sarah is, I think that's Indiana, isn't it? So, yeah, I'll check back on that in just a minute. But let's check out the current weather situation. And you can see we've got northerly flow across the central plains. And we look for that banding of the thickness. So, strongest thickness banding is kind of in this area right here. So we're going to place the front on the south side of that region, kind of in this area. So using that principle, maybe something like that from basically West Virginia to Texas to California. Now you could place it further south. In this case, I'm placing it where the tighter gradients are, but that's really where the surface chart is important. So let's scroll on over there and check out the surface conditions. And it's best to start with the warmest air on the chart. So all the way down in the Gulf of Mexico and into Old Mexico itself. So we got a lot of 70s here, a lot of 70s. There's 79 right there. I guess that's Ciudad Victoria. And some of it's coming inland. Got 71 at Corpus Christi, 71 at Houston. So I think we can use that to place a front. And we'll draw that on kind of like that. Looks like a little bit of sea breeze coming in there near Port Lavaca. And I think we're going to draw the front kind of like that. And it's a receding warm front, so it's moving northward. And we are north of that boundary, so we're catching some of the overrunning up in that area. So the question is, where does it lie out here? I guess we're going to place it along the Gulf Coast. So maybe down in this region. So we go from 70s and then down to 60s, 50s, and 40s. So that looks perfect. So when we go and do the weather map, we're probably going to want to do something like that. So we're probably going to find that a lot further north tomorrow morning. And then further up north, I'm just curious if we have a Arctic front up there, and I don't really see one. Because we do have that Arctic inversion that we saw just a minute ago. When you have a Arctic inversion, there's probably an Arctic front just to the south, and I don't know, there might be one here. Do we have a front moving down from Alberta? Let's take a look real quick. You can see lots of minus 18, minus 8, minus 19 coming through here. Very cold temperatures in Alberta. And yeah, there's probably kind of a weak leading edge of some fresh polar air working southward right there. So anyway, there's a lot to look at there on the charts, and you can feel free to pick that up on your own. And let's check out the forecast here real quick. Okay, so this is for right now. This is the GFS forecast. Showing a big surface system there in Chicago. And let's see here. Let me check and make sure I've got that on my surface chart here. Yes, absolutely. There it is. There's the surface low. It's not very deep. It's only about 10,008 millibars, centered right about there. And I don't really find much of a warm front in this area. because you can see the temperatures, they fall very gradually from about 40 to 34 to 30, then down to 26. So it's very difficult to place a warm front up here. So this is where I would go with my original positioning to the south. And I think what we have up here may be more along the lines of an occluded front, extending southward. And the only really cold air I see is way up here in this region here. So, yep, I think that's probably an occlusion right there. So, yeah, there's our occluded system right there, and I think we're looking at the warm front right there like we had it on the other charts, and that's lifting northward. And then for tonight, we're going to run that forward, and it looks like we have another surge of cold air. It looks like it catches up to that warm front and pushes it back down to the south. And there's that high pressure. So that's going to sink in overnight. And when we do the webcast tomorrow, there's that high right there, very weak high, and we refer to that as a puny front on yesterday's webcast. So it drives the front right back down to the coast, and here comes another one. New Alberta Clipper moving southeast. And then for our Tuesday webcast, we're going to see that settle across the Midwest and just drive more cold air into Texas. And we talked about backdoor fronts yesterday. That'll be working into East Texas and into the Panhandle, not so much into San Antonio and the Rio Grande Valley. So they'll stay pretty warm there. Then for Wednesday's webcast, we bring more of that cold air south. Backdoor front is pretty much in place over Texas, and lots of cold air advection into the Great Lakes area. So, yeah, if you're in Indiana there, you're just going to get more of the same. And we can see a new Pacific system moving inland, moving onto the coast there. Then webcast on Thursday, got continued high pressure moving south, continued cold air advection on the Great Lakes, and good lake effect snows there. And we start redeveloping this warm advection across Texas. Backdoor front pushing all the way up to the mountains. And now we're going to get kind of a cloudy, drizzly pattern here in Texas on Thursday. Then for Friday, things start to go downhill in the Rocky Mountain region right there. If we actually place the front, we're going to probably find that kind of like this here. Then maybe a warm front kind of like this. So things will be warming up in Texas, finally, it looks like. Just for a brief window. But we got high pressure right up to the north, Canadian high just up there in the Dakotas. Looks to be another shot of wintry weather there, parts of the Great Lakes on Saturday. And we get more cold air sinking south on the run-up to Christmas. And this is where we see that those pressure falls way up there in Canada. See that 984 millibar low right there. That's going to be detrimental to Arctic air production. So we'll see kind of a mild period of weather about a week to a week and a half from now. And then the models start catching up to Christmas Eve here. This is the 312-hour forecast. Still not within the window for this to be accurate, but we can still look at that. It's painting out kind of a zonal picture here. The thickness lines kind of run from east to west, or west to east rather than north to south. So things will probably be a bit mild. But I can see at the very end here, you can see it brings a big chunk of cold air southward. And that could be the GFS bias coming in once again. And the fact that this low is coming from British Columbia and going all the way to Texas, I'm not too sure about that. But if it does happen, that looks to be a very cold air mass. That's a 522 decameter thickness line all the way down to the Red River. So if that actually happened, we would be talking about 20s for highs and maybe even teens in some areas. All right, let me take a look at the chat. And all right, got a few locations for some people. I'll write that down towards the end of the outlook. And I've got a new feature for you guys. Yes, this is the building blocks, and what I'm going to try to do here is cover kind of a bite-sized weather concept every day, just kind of short and sweet, and just cover things, little elements a bit at a time. What I'm going to cover here is mixing ratio. Mixing ratio is just the ratio of the mass of water vapor to the mass of the rest of the air in a parcel, an imaginary volume of air. And let's see, I've got another graphic here. For instance, if you have 9 grams of water vapor in this box right here, and the rest of it measures 1 kilogram, we refer to that as 9 grams per kilogram. Now, 1 kilogram of air, that's going to be roughly about 1 cubic meter, if you want to kind of like think of it visually. But in any case, 9 grams per kilogram, that's going to correspond roughly to a dew point, maybe, if I'm remembering this right, about 50 Fahrenheit. But the important thing about mixing ratio is it's a conserved value. Dew point, that will change depending on what the pressure is. If your parcel rises or falls, the dew point on that is going to change. But mixing ratio is constant, so it's better. It's actually a better measure of the total water vapor in the air. And let me see if I've got an example of that. This is an example of mixing ratio in use. This is a LiDAR plot in Ontario. It's basically kind of like a radar that points upwards, and this particular one is able to detect moisture. And you can see mixing ratio right there. You see the values there, those are actually pretty low, so this might be kind of a cold event, but it's picking up some higher values of water vapor there and there, so those could be clouds or stratified upper layer. But what's important to keep in mind is clouds are more tied to relative humidity, not to total water vapor. So this is really only telling us where moist layers are, maybe not exactly where clouds are, unless there's some advection going on right there. So another good use of that would be water vapor imagery. That's basically detecting water vapor. And this is a graph from SPC, a chart from SPC showing a plot of surface mixing ratio. This is kind of hard to read. The chart is kind of jumbled. The red lines are theta, which is potential temperature, but we can remove those and we get this right here. This is a current plot for mixing ratio. And this is basically showing us the moisture that's advecting northward. And so there's our moisture axis. So basically mixing ratio, it's the same basic principle as dew point. They're very closely tied together. And it's basically just a measure of total moisture at that particular layer where you're measuring it. Okay, let me see if I have anything else. That's it for our bite-sized block weather. I forgot what I called it, weather block, so still got to get used to that. But anyway, I think we're about done here, and I appreciate you watching. And let me check the chat and see if there's any questions or comments. Nothing really. Thumbs up on the building block segment. Yeah, I appreciate it. We'll try to do that every day, as long as I remember and we check that out. Kevin says, still way behind on rain totals in East Tennessee, but at least since the last rains, the air quality is better. That's good news. Probably good news for the fires there. Anyway, thanks for joining, and we'll see you tomorrow. And have a good one.
And the others, they believe in school.